Page 4 is going to start off with some titrations, so I'm going to need this formula again. Only this one, it looks like it's the dilution titration, but it's actually the dilution formula. It's actually going to also serve as the titration formula. M1V1 equals M2V2. M1V1 equals M2V2, where we're dealing with the hydrogens versus the hydroxides. This is one of the old ones, the original ones. It's a 1-to-1 ratio, so there's no fancy extra math that we have to do because the hydrogens and the hydroxides are to a 1-to-1 ratio. So it's simply, what's the molarity of the unknown acid? Well, the molarity is what I'm trying to figure out. I had 25 milliliters of that. Some people ask me, do I have to change that to liters? Nope, that formula, volume, just says volume. It does not say it must be liters. It's titrated with 0.5 molar, that's the base, and they used 2.7 milliliters. 25 milliliters, 25 milliliters. The milliliters will cross off. My answer is going to be in molarity. 0.5 times 2.7 divided by 25 equals 0.054 molarity. Probably the thing should say, what is the pH? I'd simply hit the log button, ignore the negative sign, pH equals 1.26. Next one's acids and base neutralizations. Go fast through these. You have to figure out that the formula for nitric acid is HNO3. The formula for calcium hydroxide is CaOH taken twice. It will always make water. I like to write that as HOH. It makes it easier for me to visualize how to balance it. And the other product is going to be calcium dancing with nitrate. Make sure that you remember that calcium's a +2, but nitrate's only a -1. I guess you don't have to remember it. Make sure you check. So that's, I'm seeing 2 nitrates on the right-hand side, so I'm going to need a 2 over there to balance it. Now I'm seeing 2 hydrogens and 2 hydroxides on the left-hand side, so I need a 2 there. That one's done. Sulfuric acid is H2SO4. Reacts with sodium hydroxide. Once again, the products will be water, which I'll write as HOH, and a different salt this time. This time sodium gets to dance with sulfate. Once again, we have to consider their charges. Sodium with a +1, sulfate with a -2. It's going to take 2 of these. I mean, I could go up here and do this. +1, SO4, -2. Crisscross the charges, Na2SO4 taken twice. Once again, to balance this one, I'm just going to do it by a visual inspection. If I see 2 sodiums over there, I need 2 sodiums over there. If I see 2 H's and 2 hydroxides over here, I need a 2 over there, and that one is done. Finally, we get to some stoichiometry, putting lots of pieces together. At this point, there's already a balanced reaction written for you, but I'm not sure if that'll be the case, honors. There's this piece of paper, and we didn't really use this, but this is my patented 5-step process. Okay, I didn't really patent it. This is kind of like a checklist of how you do any stoichiometry, and if you follow these steps, it should get you there. Then there's a couple of extra notes on the bottom in case we have certain types like percent yield or limiting in excess. So I'm going to be coming back to that piece of paper, and you do have that in your packet on test day. Okay, first one is lead 2 sulfide, reacts with oxygen, blah, 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 blah. What do I need to do? Step 1 is balance the equation, right? And balance the equation. Well, in this case, it's already done for you. Check. So read and figure out, what are they giving you information about, and it'll have a number, and what do you want to know about? Lead reacts with oxygen, that's just information. Here is a given. They're going to give you, given the fact that you start with 785 grams of oxygen, how many grams of sulfur? That's what we want to know. And so I like to just figure out right away what it is we want to know. And I'm even going to jump ahead. It must be that this is an important box because it's oxygen. And the other one's sulfur dioxide. That's this one. This is the important box. You don't have to set it up as a true BCA table, but I'll just kind of remind us. We don't have to fill in everything. But these are the only two important boxes to deal with. Step 1, balance the equation. Box around what I was given. Okay, you can't write grams into a BCA table. It has to be moles. So the next step, if I convert the grams, 785 grams of O2, how many moles is that? Well, 1 mole of O2 is 2 oxygens is 32 grams. 785 divided by 32 is 24.5. 24.5 moles of oxygen. So I'm going to write a 24.5 here. Okay, next step. Whoops. Convert to moles, yep. I set up the BCA. I even filled in the start box. I need to figure out the want box. What is it that I want to know? And so the next step over on the BCA table would look something like this. So I'm asking myself, how many moles of sulfur dioxide? I know they're asking grams, but I got to get to moles. I need to know that first. I want to know, that was a W, of sulfur dioxide. So check the mole ratio. If 3 moles results in 2 moles of, if 3 moles of oxygen results in 2 moles of sulfur dioxide, what about 24.5? Well, that will be, what do I want to know is 2 moles of SO2 on top over 3 moles of O2. That would be 2/3 as much. 24.5 times 2 divided by 3 equals 16.4. 16.4. Reality check. So the 16.4 is smaller than 24.5. Does that make sense? Yep. Because 2 is smaller than 3, you should get a smaller number. So I'm getting 16.4 moles of SO2. Let's see my little patented. So I set it up. I figured out even my want box, check. Last step is just to convert to grams, because that's what it asked, is how many grams. So how much does 1 mole of SO2 weigh? I put it down there so it crosses off. So it's an S, 32, plus 2 oxygens, another 32 is 64. 16.4 times 64 equals 1046.7. 1046.7 grams of SO2. Next one, very similar in the fact that I'm using all of these steps again, only there's some extra stuff down here because this one is a percent yield. And so I'll have to think through some of the nuances of that. Step 1 is balance the equation. You right now are in luck, it's already given to you. Step 2 says put a box around what I was given and what I want to know. Let me do some reading. 5.9 grams of SO2 is used. That's a reactant. Yeah, that's what we're starting with, that we're given that amount. Excess oxygen, I don't have to write that, but I can. It forms 7.5 grams. So there's this other thing. What that's going to be is what's called the actual. This is what was actually done. In fact, I can go right down here right now. The actual yield is 7.5 grams of SO3, sulfur trioxide. So apparently, they're only interested in sulfur dioxide, which they tell me how many grams, but not moles, and sulfur trioxide. They tell me how many grams it made. What I need to know is, I'm trying to figure out how many should have I been able to make, theoretically, based on some fancy math. Let me go look at this. Actual comes from lab data. I wrote that because I read and they said that they made it. Theoretical comes from fancy BCA math. The actual will be a product. If there's 2 numbers and you're not sure which is which, the actual's got to be a product. That's what they make as a product. And the given will be a reactant. So if you get thrown by 2 numbers, well, you can straighten that out by reading that little note. You will have access to that note that will be given to you. So first step, balance the equation. Next step, figure out what do you want to know and what you're given. I need to convert to moles before I can put this into the BCA table. So 5.9 grams of SO2 times 1 mole of SO2 is, just did that one, it was 64 grams. 5.9 divided by 64.09, I'm not sure if that sounds right. 5.9 of SO2 32, 2 oxygen, 64, 5.9. I'm liking it. 5.9 divided by 64 equals 0.09. 0.09 moles. 0.09 moles. So I've converted to moles. I've set up the BCA. I filled in the start box even. What about the want box? So go through the mole ratio. If 2 moles of SO2 results in 2 moles of SO3, what if I only had 0.09 moles? Well, I'm only getting 0.09 moles. Got my want box done, check. The last thing, convert it to grams, and then we'll look at some special stuff about percent yields. How do I convert that to grams? 0.09 moles of SO3, 1 mole of SO3, it's going to be 3 oxygens, 48 plus 32. It's going to be 80 grams, or it's going to be, yeah, you'll use your periodic table a little bit better than that. 0.09 times 80 equals 7.2. 7.2 grams. So let me see if I got this right. So that's SO3. That is the theoretical is 7.2 grams of SO3. So theoretically we can make 7.2, but we actually got 7.5. Seems impossible, but these things happen in a high school lab or any lab where we might not have got a perfect product. The last step is to calculate the percent yield. Put the actual on top, divided by the theoretical, times 100 to get the percent. If you got 7.5 grams out of a 7.2 grams possible, times 100, 7.5 divided by 7.2 times 100 equals 104% yield.